Hello everyone, I am Harshita Sri, M.Tech student at NITK. So today I am going to discuss about zero shot and few shot recognition in machine learning. So what is recognition in machine learning? Recognition in machine learning means the ability of a model to identify the patterns, objects or categories from input data. So it is a key part of artificial intelligence system used for understanding and classifying the information. So when we say recognition, there are different type of recognition in machine learning. Based on the data availability, we can divide the recognition into three categories: supervised recognition, zero shot recognition, and few shot recognition. So in this video, I'm going to talk more about zero shot and few shot recognition. Let me begin with a simple exercise. If I ask you which of the following is a numbat, maybe you can able to identify which is a numbat. Maybe it's the first time you're hearing the word numbat. So, how to identify which one of this is a numbat? For that, if I give you a hint, okay. So the hint is that it has strips across the back and a dark strip through the eye. Once I give you this hint, you will be able to identify which one of this is a numbat. So here the right-sided pick is a numbat. So what you just did is a zero-shot recognition in machine learning. Zero-shot recognition is where the model recognizes new unseen classes without ever seeing training examples of them. So it bridges a gap using semantic information like attributes, texts, or descriptions. Once I give you a description or a hint, you were able to identify the numbat. Similarly, if a model does this, then it is called as a zero-shot recognition. It works when there is no training example exists for a new class. It saves time, cost, and effort, and it mimics how humans recognize new things from description. It learns the concept, not just the patterns. So the real world adaptability of this is that it helps when new object, when new species or event appears unexpectedly. So for example, detecting a new disease or a new product type. So this is what a new zero shot recognition means. Okay. What are the methods to implement zero shot learning? So basically there are three different methods to implement zero shot learning. So first one is attribute based implementation. It uses human defined attributes to describe classes. The model learns to predict these attributes, then match to the unseen classes. So first here we will do the will do the attribute vector for each class. So for example, a bee can be a class, a mouse can be a class. So for each class, we will provide attribute. And after giving the attribute, we will train the classifier to predict the unseen attribute or unseen image. So for example, if we give a description or a attribute like yellow and white stripes, small size, and can fly. So all these attributes, the model is able to predict that if it is a bee, so these attribute corresponds to the image B. So it will map, the model will map like this based on attribute and will be able to predict the image or be able to predict the object. So that is called as attribute based implementation. So in embedding based implementation, we will obtain feature embedding and semantic embedding. Then we will then we will build a projection map that maps the image features into a semantic space. And during test time when we test unseen data or unseen image, we'll compute the semantic embedding and of unseen sample, and then we will try to map it with the feature embedding, and then we will try to predict the object. So that is what happens in embedding based implementation. The third one is generative model implementation. So here the model generates synthetic examples of unseen classes using their semantic descriptions. So once we give the image, we will give the semantic description, and based on that, the model will generate unseen classes, and then we will try to match it with the unseen class and predict the object or predict the image. So these are some of the methods to implement zero shot learning. So next, okay, let's do another exercise. So here on the left side, these are images of chinchilla, and the right side, these are images of a mouse. So once you find the images of these two, let's go for a quiz. Okay, is this a chinchilla or a mouse? So based on the images that I've provided in the previous slide, you will be able to identify that this is a chinchilla. So when a model does the same thing, it is called as few-shot recognition. So few-shot recognition is a technique in machine learning where a model learns to recognize new classes only using few training examples, typically 1 to 5 images per class. So here in the previous slide, I have given two images per slide, two images of chinchilla, two images of mouse. So basically when you give the model few shots, few images per class, by training on these examples, if the model is able to identify the object, then it is called as few shot recognition. So this is a solution to a problem of data scarcity in machine learning. So using this we can work with very limited labeled data. It reduces data collection and labeling cost, and it enables learning in rare or data scarce domains. Okay, what are the methods to implement few-shot learning now? So, Siamese network. Siamese network learns to measure the similarity between the images. So, it will find what is the similarity between the images, and based on that information, it will predict or it will recognize the image. In a prototypical network, it creates a prototype or average for each class and classify the new example based on the distance. So maybe a Euclidean distance. So it will create average for each class, and when during testing it will measure the distance, and based on the distance it will be able to predict or it will be able to recognize the image or recognize the object. The third one is the generative model for few shot. So this is similar to generative model for zero shot, where the model will synthesize unseen classes based on the semantic information that is provided, or based on the images here, based on the few images that we have given, and they'll train the model will be trained on a normal classifier using both seen and unseen data, and using this data the model will be able to recognize the image. So this is how the few shot recognition or few shot learning works. So now you got a basic idea about zero shot and few shot recognition. Now let us see what is the difference between zero shot and few shot recognition. So uh, okay, let's see the difference based on these features that I have provided. Okay, training data for new classes. In zero-shot recognition, no training examples are available. Only semantic information we will provide to the model, and based on the semantic information, it will recognize. In few-shot recognition, only a few, like 1 to 5 examples will be given. 1 to 5 images will be given for the model. And you do okay, knowledge source. It uses semantic descriptions, text, or attributes of class. But in few shot recognition, it learns directly from the few examples that we have providing. Based on the data requirement. In zero shot, no label data for unseen class. But in few shot, very small label data set is required. And common use cases. So zero shot recognition can be used in image classification, natural language processing, and robotics. Whereas a few shot recognition can be used in medical imaging, personalized recognition, or rare species recognition or rare species detection. So this is a major difference between zero shot and few shot recognition. Okay, I hope you got a basic idea about what is a zero shot recognition, what is a few shot recognition. Now let's dive deep into zero shot recognition, and I'll explain one of the application where we use zero shot recognition. Open vocabulary image recognition. So this is a modern computer vision approach where a model can identify or describe the object it has never seen or explicitly trained on, simply by using textual or language description. So this is a large scale extension or application of zero shot recognition. So Here, open vocabulary image recognition means recognizing anything you can describe in words. So this is an interesting application of zero shot recognition. So I will explain how exactly this works. Okay, in this there are two different phases. One is a training phase, another one is a recognition phase or inference phase. So in training phase, the model is trained on hundreds of millions of pairs from internet or pairs of image with text caption. So one of the major misconception about the zero shot recognition is that we think that in zero shot there is no image is provided for the training. So it is not like that. Zero shot just means that the image that we have providing, the image that it will recognize is the image which it never seen before. It doesn't mean that we never train the model with any image. So in zero shot recognition or zero shot learning, we will provide the model with a lot of trained information, and using these seen information or seen data, the model will predict or model will recognize unseen data. So that is what zero shot means. So the model should be trained on hundreds or millions of pairs, image along with the text caption. So two different encoders will be used here. Image encoder, which will convert image into a vector or image into an embedding, and text encoder, which convert caption into a vector. So this image encoded embedding and text embedding. So both will be stored in a similar embedding. So the training objective means matching pairs, image plus correct caption. For example, if we provide image of a cat, the description will be if this is an image of a cat or cute cat like that. So this both image embedding and text embedding will be stored in similar embedding, means the distance will be very less. So non-matching pairs will be far apart. This is done using contrastive loss. So this is what a training phase is. After training phase comes the inference phase or recognition phase. So in recognition phase, when given a new image, model creates its image embedding. So when we provide the model with a new image, the model will first generate its image embedding. Then you have to provide a list of possible labels in the text form. Like for example, recognize photo of a cat. For example, if you give an image of different animals in them and ask the model to recognize image of a cat. So first it will create image embedding of that image, and then it will try to match it with the existing or the trained text embeddings. So the model will compare the image embedding to each text embedding and select the one which is most similar. So this allows recognition of unseen objects as long as they can be described in language. So this is how zero shot recognition can be used in open vocabulary image recognition. So I hope you understood what is this. So there will be two phases. First, the model will be trained with millions of pairs, image and text embedding pairs, and based on that, when a new image is given, it will convert into image embedding first, then it will try to match with the existing or the prior text embedding, and based on the similarity, it will take or it will recognize the object or it will recognize the image. So this is what happens in open vocabulary image recognition. So one of the fundamental or famous example of open vocabulary image recognition is CLIP, contrastive language image pre-training. So here this model is developed by OpenAI that learns to connect image and text in a single shared understanding. So this is one of the important or a major example of OVIR, that is open vocabulary image recognition. So this uses the concept of zero shot recognition or zero shot learning. So this model works exactly like what we have discussed. That is, it will have two phases, training phase and inference phase. In training phase, we will provide the pair of image and text, and based on that, it will find the embedding. And from that embedding, when a new image is provided, it will try to match the embedding and will recognize the object. So this clip is an application of zero shot recognition. So maybe in another video I can explain more about this clip. So here I'm about to conclude the topic, that is zero shot and few shot recognition. So okay, let me conclude. Zero shot recognition is where the model tries to predict the unseen data or unseen image based on the semantic information or text or description that we have provided. Few shot recognition is where the model tries to predict or model tries to recognize the object based on the few shots, few examples of image of same class. So this is the major difference between zero shot and few shot. So this finds application in computer vision, medical application. There are many applications. So one of the application is this CLIP, contrastive language image pre-training. So I hope you learned a few new things about zero shot and few shot recognition. So that's it about this video. That's it about zero shot and few shot recognition. So thank you.